Okay. So again, the amplitude is typically none, but in this case, like if you wanted to know what the A value would be, it's just 1 here. But this is our B value. So the period is pi over B, which is pi over 2. So that makes graphing this a little bit tougher. So I'm going to talk to you a little bit about how that works then for our graph here. So what happens then, since basically the period is half of the normal, that's going to change where our asymptotes are. So that's going to make this a little bit trickier. So just like we normally have, so tangent goes 0, u, 0, u, same thing over and over again. It's still going to do that. It's just going to do that more frequently because the period is half of the normal period. So normally there's asymptotes at pi over 2, 3 pi over 2, kind of like that, but we're doing half of that. So where will our first asymptote be then? Pi over 4. So there's going to be an asymptote at pi over 4. And then also negative pi over 4. And there is no phase shift or vertical shift that we have to worry about in this case. So it starts at 0. Remember, tangent goes uphill. And the whole period is pi over 2 wide. So a quarter and a quarter is a half. So that being said, where is my next asymptote going to be? Yeah, and just kind of use this as our pattern. It basically goes 0 asymptote. So that's going to be 3 pi over 2. Or 4, sorry, right? Because this is going to be pi over 2. And again, skip it. Because this will be pi. So this will be 5 pi over 4. And that's probably good. Once we have a couple of those, you can be done with that. All right, we'll look at our next one here is cotangent. So remember, going right into this, cotangent goes downhill now. So kind of a few things we want to make sure we know about cotangent. So right away, I'm going to maybe like make a little mark to remind me cotangent goes downhill. The amplitude technically is 3, but not really because the amplitude doesn't really change. So this one's going to be a little bit like more of a straight line kind of ish, like it'll be like not as curvy as the last one. But that wouldn't be graded. I'm not going to be like, oh, yours wasn't curvy enough or this is too curvy. Like, I mean, so don't worry. I might ask you about that number, but that's about it. Now this time is good, or this one's a good one because the period doesn't change. The B value is just 1. So the period is just 5. Now cotangent typically begins with an asymptote. So it goes undefined 0, undefined 0. So this one has asymptotes at 0, at pi, 2 pi, 3 pi, all the normal whole values. However, what's this graph doing? It's shifting. It's going to the right pi over 2, a phase shift. So what do you think that's that's going to do to my asymptotes? They're going to shift over as well. So rather than being at 0, pi, pi over 2, 3 pi, they're going to shift over one space. So normally, and I'm going to put these as, I'm going to do pi over 2 here, I think. Or should we do pi over 4? Pi over 2. Yeah, because that's where we're shifting anyway. Pi, 3 pi over 2, 2 pi. All right, so normally there's an asymptote here, but we're shifting it. So then the 0 would show up here, but remember it goes downhill. So make sure your graph goes downhill. And you're trying to hit the 0 in the middle. If you miss it, make an attempt at hitting that in the middle there. So this one goes downhill, shifted over. Again, going back and double checking that the period is as wide as we expect it to be. So from 1/2 to 3.5, that's 1 pi. That's what we wanted the period to be. The amplitude was 3, but that just makes it like, it's supposed to make it like skinnier, or like straighter, I guess. Not really skinnier, like a straighter line. But again, mine all end up looking the same. I don't know that mine all that different. All right, so this one's kind of, I feel like a little bit more basic of a tangent graph. However, the shift it does might change our units of what we want to do for our measurements here, or our marks on our graph. So again, amplitude is just 1, so normal tangent graph. The b value is just 1, so the period is just pi. Again, there's no vertical shift, but there is a phase shift. We should be going right pi over 4. Now tangent normally starts at 0 and goes undefined, 0, undefined. But that's going to be shifted over. Same thing with our asymptotes. Normally, we have an asymptote at pi over 2. It's going to move over. And so what I'm going to suggest is that you do your marks on your graph a little bit differently. Rather than doing pi's over 2, I would do pi over 4 here, right? Because that's where we're moving it. Which would make this pi over 2. So this would be pi, this would be 3 pi over 4. So normally I have an asymptote at pi over 2. It's going to move over one space. Normally there's an asymptote at negative pi over 2. It's going to move over one space.
So why is it pi over 2?
What's that?
Why like starting from
Because that's normally where our asymptote is.
oh,
So in tangent, our asymptotes are normally on the halves. So we're just shifting it over one space. So I'll get over here to like pi over 2. There normally would be an asymptote, so there'd be one here. But this looks wider because we changed our spacing. You know, we changed our units. Now again, it should be 0, or it should go through 0 at the middle of this. So it should go through 0 at pi over 4. And again, tangent should be uphill. And they do, again, they give you the spacing on here. Hopefully that doesn't throw you off too much. If you absolutely hate the spacing they do and you want to have your own graph paper, I do have other graph paper. All right. So then we have 2 plus 3 times the tangent of x. So what do the 2 and 3 stand for?
Oh, 3 up 2 is up.
So 3 is going to be our amplitude, I heard that. So again, doesn't really change anything. But the 2 tells us to go up 2. And this is kind of a strange one. So when it goes up 2, you have to think about where the middle line normally crosses. It's almost like you picture the axis like just moving up 2 as well. Now this one has the same period that we're used to because the b value is just 1. So I would probably make our spaces on this one pi over 2. And again, tangent starts at 0, goes undefined, 0, undefined. It has an asymptote at pi over 2, 3 pi over 2. All the halves have asymptotes. And again, this just takes some practice. So every other line should be an asymptote, again, because we know the period is pi, and it's going to go uphill. But again, what we really care about is where it crosses 0. It should cross 0 right in the middle, but this time it's going to shift up 2. So I'm going to put like a dot there, so I know then to have it cross in the middle. So that shift just moved our graph up, and so the middle of the graph just shifts up as well, if that makes sense. So it should look different than our normal tangent graph would have been lower than that, like so the middle of it should be up. Is that okay? All right. No. You hated it before you learned it.
Put the asymptote. Like, I don't get why.
Yeah, why is it cheap?
Because it says so.
It's just a vertical, or sorry, this should be, sorry, I wrote this in the wrong set. A phase shift, the one when you move left and right, then it switches it. Or if the period switches it.
I understand, because the period 1 though, so how this works.
Well, the period, we're here.
Thinking now you can have half
That was the tangent before you shift them. Yeah, they shift, they move as well.
Yeah, I get that.
Period change.
Yeah.
So yeah, on those of you guys online, we really quick here. Going back to this is the default, and these asymptotes can change. Whoa, don't move on.
Oh, don't
They can change. They can change if I move them around. They can change if you have a phase shift or if your period changes. That's going to change these asymptotes. So that's when those change where they are. So the phase shift and the period changes are the two that cause wreak the most havoc on these. So that changes where your asymptotes are. Because technically the asymptotes moved in secant and cosecant as well. We just weren't listing them. That's probably the easiest way to tell what the graph looks like is knowing where those asymptotes are. So let me know though. Feel free to work together. Just real quick on this, the first. I don't know if I know yesterday some of you guys were getting bothered by the thetas. I'd be glad to do the first one with you just because of the notation, if that's helpful. Oh, sure.
You want to give us the homework?
I didn't go over it. I put on a cover.
Shut up.
Okay. So guys, I'm just going to do this first one. If you guys want to do this with me, if you don't need any help, feel free to ignore me.
Bless you.
This is, oops, not that. This is the same thing. So don't let that theta scare you. So this is theta over 3 is the same thing as 1/3 x. So don't let that bother you. So that's my A and my B. So that B is important because that's going to change my period. It's pi divided by B. So pi divided by 1/3. So this one's going to be 3 pi, right? Now if you look at their scale they chose to use, 3 pi is pretty far down the line there, right? Now normally tangent has asymptotes at the halves. However, this graph is a third, like 3 times as slow as another one. So where are the asymptotes going to end up being? Let's just think for a second and I'll talk to you.
Why can't they be on the halves?
Because if they were still in the halves, so let me show you that. If they were still here, the period is only pi long.
Oh.
Okay? We need it to be 3 pi. What? Close. It's not going to be at the, because they're never at the whole values with tangent.
3 pi over 4. 2.
Over 2. You basically multiply this by 3, just like we did here. So the period's multiplied by 3, so we're going to do the same things here. Oops, oh, I didn't mean to do that. I wanted to erase just this. Oh gosh. Okay, so let's fix that then. So let's change this. So this is their unit, so I'm just going to use that because that's what they're using. So my tangent needs to be 3 pi wide. However, it's going to look like a pi and a half on each side, or 3 halves pi on each side. So my new asymptotes are 3 pi over 2, 9 pi over 2, but also remember negative 3 pi over 2. You can put them there. So that's really the only one I'm going to see. So the next one, I don't think it goes that far on yours either. Oh, yours does show 9 pi over 2. You could put one there.
So the period actually chooses the asymptotes.
Yeah. The asymptotes are only in that spot if the period is the same and there's no horizontal shift. Now, if that's where my asymptote is, and the next one is back at negative 3 pi over 2, there's still a 0 at 0. If I can get that to go through there. So this is just going to be this super wide graph.
Yeah, it's pretty wide.
That's just going through, and then the next 0 should be at 3 pi. The reason for that is because if the first 0 was at 0, the next time it's back there again is a full period away, so at 3 pi. All right. Why don't I give you guys a little bit of time to work? If you get stuck on something as you guys are working ahead, we can always